Hey everyone. So I hope all of you are doing good. So guys, in the last lecture we have started the optimum product mix, which we will complete in this lecture. So basically, I told you in the last lecture that there should be like two types of question related to optimum product mix. Like one type of question would be there where the resources, some of the resources are in limited quantity, or I can say one of the resources in limited quantity. So we need to find out which would be what would be our optimum product mix, or in what ratio we should make our product so that we can get the maximum contribution. So that was the first type of question, and we have done one question related to like that that concept as well, which is belonging from CMA final study material. I hope you got the question. So due to some reason, I couldn't record the second question as well in the last lecture. So basically, in today's lecture, what we'll do, we'll we'll do two questions on optimum product mix, because I really feel that optimum product mix is a important topic. So we'll solve one question from CA final material and one question from CMA final material, so that initially you can understand the concept in full. Okay, and after completing decision making, we'll go through all the chapters available in CMA final study material, because we are doing the CA final question along with the like the chapter. Like we'll do it in next 4 to 5 lecture when I'll make you understand the concept. We'll do those questions along with the concepts. So since there are more questions in CMA final study material, so we'll solve those questions after completion of this topic, decision making topic. Okay, so I hope you got the topic. I hope you are enjoying the decision making, because I really feel that this topic would cover sufficient number of marks in your examination, and it is somewhere interesting as well. So let's move to the question in CA final material. First, we'll do the question where two or more resources are in limitation, so that we can use the linear programming to solve the question. So illustration number 9 is there. I hope all of you know that all the question in the section of test your understanding, test your knowledge. Sorry. So all the question which is in test of knowledge is for your homework. So you guys need to do all the question which is there in test your knowledge section of CA final study material. If I talk about the CMA final study material, like we are solving a few questions along with the topic, but at the end, we'll once go through all those questions available in the material. We'll see what question we have done, what question we need to do more, and what would be your homework. So that will decide in the last. So let's come to illustration number 9. A company manufactured two products. Each product passed through two departments, A and B, before it becomes a finished product. Okay. The data for the year are as follows: product X and product Y. So one thing that in the linear programming question, you need basically a graph to solve these questions. Okay. I hope you guys know what is linear programming. Linear programming means the question which is solved using the X and Y, like we put X and Y, we calculate different values of X and Y, then we make a graph. Okay, and by using the graph we use to solve the questions. Okay, so data for the year are as under. The data is given to us for product X and product Y. So basically maximum sale potential is 7,400 units and 10,000 units. Product unit data, I can say selling price per unit 90 and 80, machine hours per unit. Basically in department A the rate is rupees 40 per hour, but it is saying machine hours per unit. So basically for product X we require half an hour in department A, and basically 0.4 hour in department B. And in product Y we require 0.3 hour in department A and 0.45 hour in department B. Sorry. And the maximum capacity of department A and department B is given to us. Okay. Along with this, maximum availability of direct material is also given to us. So basically there are three limiting factors given to us in this question. The first limiting factor is hours available in department A. The second limiting factor is hours available in department B. And third limiting factor is material. Each product requires 2 kg of direct material. Okay, the purchase price of direct material is 5. So find the optimum product mix. So let's come to the sheet. Just a second. Illustration 9 from CA finance statement. Okay, guys. So let's calculate first that what is the limiting factor. So let's see that what basically for different type of factors, for different limiting factors, what is our requirement and what is the availability. Okay, so I can say for material, for R in department A and hour in department B. Available. Available, I can say material is available 17,000 kg and department A and B are still available 3,400, 3,640. R required for product X and product Y. I can say how many direct material is required. It is just a second, 7,400 multiplied by 2, and for product Y 10,000 multiplied by 2. So I can say 20,000 and 14,800. Okay. In the same way, let's calculate the department A hours. Basically 74 multiplied by 0.5 and 10,000 multiplied by 0.3. For department B, 74 multiplied by 0.4, 10,000 multiplied by 0.45. So I can say 4,500 and 7,400 multiplied by 0.4, it would be 2,960. It would be 3,700 and 3,000. So I can say total required is 34,800. It is total required 6,700. It is total required 7,460. So I can say what is the shortage? It is in shortage of 17,800 kg. It is in shortage of 3,300 and it is in shortage of 3,640. It is 38, 3820. So guys, what we have basically prepared, we have calculated that whatever requirement was, it in all these three factors, we are available with lesser with what we require. I hope you are getting that. Suppose in uh, if I talk about the material, I require total 34,800 kg of material to fulfill my sale potential. To fulfill my sale potential, I require 34,800 kg of raw material, but I am available with only 17,000 kg of raw material. If I talk about department A, I require 6,700 hours to fulfill my sale potential, but I am available with only 3,400 hours. If I talk about B, I require 7,460 hours, but I am available with 3,640 hours. So basically, all these three factors are in shortage available to us. So basically, how we will solve this question? We'll solve this question by using linear programming. So what is basically linear programming? Since two or more factors are in shortage, we will use linear equation to solve question. Now, linear function of. So basically, suppose units optimum, even I would say optimum unit of product X is X, and optimum unit of product Y is Y. Suppose that optimum unit which can be made, suppose final answer which I'm getting, I'm calculating basically optimum mix of product X and product Y. So suppose that optimum unit which should be manufactured of product X is X, and optimum unit which should be manufactured of product Y is Y. So basically, if I talk in respect of material, what would be my linear equation? I would say that per kg of raw material, basically 2 kg of raw material is required for 1 unit of X. So for X units, I would require 2X material. I hope you are getting X is the total. Suppose at the end you will get answer that 100 units of X is to be manufactured, 200 unit of Y is to be manufactured. So basically, I would say that total 2X, basically for one manufacturing 1 unit of X, you require 2 kg material. So manufacturing 100, you require 200 material. So basically, this is only the thing. So basically, for manufacturing X unit of product X, even rather than writing X and Y, it would be somewhere confusing because product name is also X and Y. So rather than X and Y, we'll say A and B. I think that would be easier to understand. So 2 multiplied by A plus 2 multiplied by B. Now it should be less than equal to 17,000. What is less than equal to 17,000? Because maximum available material to us is 17,000 kg. So we cannot spend more than 17,000. We cannot spend more than 17,000. If I manufacture A number of units of product X, if I manufacture A units of product X and B units of product Y, so for making A units of product X, you require 2 multiplied by A, or I can say 2A material. For manufacturing B units of product Y, you require 2B material. I hope you are getting. Okay, why 2A material? Because suppose A is the number of units, so 2A is the total material which is used in making product X. So the first linear equation is 2A plus 2B is less than equal to 17,000, means we can maximum use 17,000. The second thing is, sorry, not labor, I can say department ARs. Department AR. So I can say what is the R basically required in for making product X, we require in department of 0.5 hours. So I can say 0.5 A plus 0.3, 0.5 A plus 0.3 B would be less than equal to 3,400 hours. This would be department AR. What is department BR? So for department B, I can say 0.4 0.4 of A plus 0.45 of B would be less than equal to 3640 R. So these are the three equations. Okay, these are the three equations which we have created. There would be two more equations. Basically, two more things are given to us that product A, basically product A can be maximum produced of 7400 R. Basically, A could be less than 7400. A could be less than 7400. Okay, because maximum potential of A, maximum sale potential, we are saying maximum sale potential of A is 7400. And I can see maximum sale potential of Y is 10,000. So these are the five linear equation which we have created. Linear equation 1, 2, 3, 4, and 5. Now using these five equation, we'll prepare a graph. Now how the graph would be prepared, let's see. So for material, basically to prepare the graph, what you require points, you need to draw the line. We'll make the linear graph. Okay, so to make the linear graph, you require lines. How the lines would be created? By using the equation. Just see the material. I can say 2A plus 2B is less than equal to 17,000. Now, how the different points would be created? Suppose A is 0. So firstly, put a point that I am making 0 units of product X. So A is 0. So what would be the B? B, I can say B would be less than equal to 8,500. Yes, B would be less than equal to 8,500. Suppose B equal to 0. So A would be less than equal to 8,500. So basically, what is the first point I have created? 0, 8 by 5,000, 8,500, or 8,500 and 0. These are the 2 points which we have created. Okay, so basically these are the 2 points which we have created. We can create more points as well. We can create more points as well, but I don't think we require more points. Why I'm saying we don't we require more points? Why I'm saying we don't require more points? Because you know, how many points will create? There can be n number of points. You can put one over here and you can get another value. You can put one in A and you can get the value of B. So there can be n number of points. So best thing is just put 0 at both the places. Whenever the question like this would be there, what you need to do? You need to put 0 in first point and calculate the value of second. Then put the 0 in second and calculate the value of first. So this is the best method. So I have created 2 points for material. I can say for labor, not labor, sorry, for department A. For department A hours. So I would say, what is the equation? 0.5A plus 0.3B would be less than equal to 3,400. Okay. Now suppose again, suppose A equal to 0. So what would be the value of B? So B's value would be 3,400 divided by 0.3, 11,333. Suppose B equal to 0. So what would be the value of A? 6,800. So basically I've created 2 points, 0 and 11,333.33 and 6,800 and 0. So this we have created for uh, the second line. I can say for department ARs. Now for department B. Zero point 0.4A plus 0.45B divide less than equal to 3640. Okay, so suppose A equal to 0. So the value of B would be 3640.45. It would be 8088. Even I would say 8089. So 08089. And suppose B equal to 0. So value of A would be 3640 divided by 0.4. It would be 9100. Okay, so these 6 points we have created. Now there are two more linear equations. So I am saying that A is basically A is less than equal to 7400. A is less than equal to 7400. So like we won't create any kind of 2 point system, because in this question we are having only 1 point. So how the line would be created in this point? Like I can say for A, suppose this is the graph. So for A, I can say A would be created where A would be A means X. A means X. Okay. So A would be created on X. So I'm saying X, the value of A is 7400 or less. So I would say that this is the line and the value of X would be less than this. Value of X would be less than this, always less than this. Okay. And for Y, I can say if the value is 10,000, so suppose 10,000 is here, B is for B 10,000 is here. So suppose I will say that this would be created like this. Okay. So we have created points. Now we require graph for making the question. So rather than making it in the graph, because we cannot get that much level of perfection, let's see it from the book only, how the graph is created. So this type of graph would be given to you. This type of graph would be given to you. So basically we have drawn the lines. So I can say first point, first we were having the point 8500 and 0 and 0 and 8500. So line is here. If you see this line, this point, zero and 8500 and 8500 and 0. So this is the first line which is created. The second line is 6800 and 0, this, and 11333 and 0. So this is the second line. The third line is 0 and 8089 and 9100 and 0. So this is the third line. Now for 7400, I am saying that 7400 is here. So since value of A is less than 7400, I have created a point of 7400 and the value would be less than this. And for Y, I am saying that the value of Y is 10,000. So the value would be less than 10,000. So by this, we have basically created a graph. Now, how the solution would be given? How what would be the solution? So basically, we are calculating it. Why we are drawing these two lines? Just a second, sorry. Why we are drawing these two lines? These line of x2 and x1. Why we are drawing this line? We are just saying that the value of A and B cannot be more than this. This is the maximum limit. Now, since these lines are intersecting below this, then we do not have any problem. These lines are intersecting over here. All these three lines are intersecting over here. Okay. So basically, we are getting 3 points where these lines are intersecting. So the first point is, if you see wherever the lines are intersecting, the first intersection point is this. The first intersection point is this. The second intersection point is this. Basically, these points are created over here. I'm sorry. Okay. So they have already created points. Okay. So STQ, 3 points are there. STQ. Okay. And 2 points are 0, 6, 6800. Okay. So they have taken one point like this, and eight zero eight nine and 0. Okay, okay, okay. I'm just trying to see what they have done, because as per me, whatever they have done is wrong. Just wait for a while. So guys, let's see. Let just leave whatever they have done. So basically, what we are seeing by making the graph, what is the purpose of making the graph? So purpose of making of the graph is just to see which of the lines are intersecting each other. Which of the lines are intersecting each other. Basically, I'm seeing that here at this point, these two lines. I can say the line of uh, this 0.4x 3600, or I can say department 2 line and material line are intersecting at this point, at point S. These two lines are intersecting. At point T, the two lines of the department 1 line and department, sorry, material line. These both are intersecting at point T. At point Q, the department 1 line and department 2 line, both are intersecting each other. Both are intersecting each other. Okay. So basically, we'll solve these three. Basically, these points cannot be get by using the graph. How we'll get these points? So we'll let's go back to the sheet. So basically, I can say that these three lines are intersecting. These three lines are intersecting each other. Now calculate the point, basically intersection points. Okay, so how we'll calculate the intersection point? The intersection of material and department A. How we'll calculate the material in department A intersection? I hope you guys know how to solve the linear equations. So basically, the material line is 2A 2B, 2A plus 2B is 17,000. And even I would say less than equal to, but let's forget the less than equal to sign because we are calculating, we are basically solving the linear equation. And 0.5A plus 0.3B is 3400. 0.5A plus 0.3B is 3400. Okay. So basically, I hope you guys know how to solve these type of questions. So multiply the second equation, multiply with 4. So if we multiply it with the 4, it would be 2a plus 1.2b equal to 34 multiplied by 4, 3400 multiplied by 4. It would be 13,600. And since now you can change the sign of everything, like if you change the sign of the second equation, it would be minus 2a. Just change the sign here as well and here as well. So it would be 0.8b equal to 0.8b equal to, I can say, sorry, just a second, 3400. So b would be 40 to 50, 40 to 50. And by putting the value of b in any of the equation, suppose put the value of b in equation 1. So what would be the value? Multiply by 2, it would be 8500, and 17,000 plus 8500, sorry, minus 8500. So it would be 8500 divided by 2. So it would also be 4250. By putting the value, if in any of the equation, you will get the value of a as well. So the two intersection point of a and b is basically two intersection point is, we have calculated two intersection point. It would be 42 and 40 to 50 and 40 to 50. So 2 points are basically, first scenario is either you can make 40 to 50 of a and 40 to 50 of b by using material and department A line. Okay. Now the second can be intersection point of material and department B line. Okay. So 2a plus 2b equal to 17,000 and 0.4 and 0.545. 0.4a plus 0.45b equal to 3640. Yeah. So multiply with 5. If you multiply it with 5, it would be 2a plus 0.45 multiplied by 5, it would be 2.25. B equal to 3640 multiplied by 5, it would be 18200. Now change the sign, minus minus minus. So what would it be? It would be minus equal to minus 1820. Now solve this. So 18, no, not 1820, 1200, sorry, minus 1200. So it would be, the value of b would be 4800. And by putting the value of b in any of the equation, you will get the value of a. So 4800 multiplied by 2 minus 1700, 17,000 divided by 2, it would be 3700. So by solving these equation, the second thing which I'm getting is 3700 and 4800. Okay, now intersection of department A and department B line. So basically, I can say 0.5, 0.3, 3400, 0.5a plus 0.3b equal to 3400. 0.4a, 0.5b. Look, most of the teachers I have seen, because I have taken classes, most of the teachers, do not go so deep in this these type of question, the linear programming question, because they even don't know how to solve these type of question. But I really like maths. That's why I somewhere try to go in deep in all these questions, and this question can be solved by this way only. Okay, you cannot find the points in the graph, you can find the points like this only. So multiply it with 4 and multiply it with 5. Multiply. So the first equation would be, if I multiply it with 4, it would be 2m plus 1.2b 13,600. 2a plus 1.2b equal to 13,600. And if I multiply it with 5, it would be 2a 2.25b. 2a plus 2.25b equal to 18,200. Okay, so this question this question cannot be solved other than any other way. Like, this is the only way to solve the question. Okay, so that's why most of the teachers do not touch this question. Okay, so it would be 0. It would be 2.25 minus 1.2, or I can say 1.0. Sorry, minus 1.05b equal to 18,200 minus 13,600, 4,600. So the value of b would be 4,600 divided by 1.05, or I can say it would be 4381. And by putting the value of b in any of the equation, the value of a you can get. So 4381 multiplied by 0.45 minus 3640 divided by 0.4. So it would be 4171. So basically you got 3 points, 4171 and 4381. So where the lines are intersecting, you got 3 points. What 3 points you got? So intersection point for x, for y. So first intersection point is 4250 and 4250. 4250 and 4250. 37 and 4800. And the third point is 4171 and 4381. 4171 and 4381. So these 3 points we got. Intersection point, basically these 3 points where the intersection of different lines are happening, we got these 3 points. Okay, now by using these 3 points, how we'll solve the question? uh, if you see we are basically having 2 more points. If you see the graph, let's go to the graph. Where the lines are intersecting the x axis and where the lines are intersecting y axis. So firstly, the basically lines are intersecting x axis and y axis at different points. Like it is intersecting at 8500 as well and 8089 as well. Here it is intersecting 68, 85, 9100 but where it is first intersecting point x and y, where it is first intersecting x and y. So it is first intersecting x at this point 6800 and 0. So we will take these 2 points as well for our consideration. We will take these 2 points as well for our consideration. For which consideration? For calculating, just a second. For calculation of the profit. So intersection point, we got 3 points and 2 more points would be there. First is 6800 and 0. The second would be 0 and 8089. Sorry. 8089. Okay. So these are the 2 points. So basically we got the 5 points. We got 5 points where the intersection is happening. Okay. So at these 5 points, intersection is happening. Now we need to see which point is the best. Which point is the best. So what you need to do, we need to see the whether at all these 3 points, the material direct, firstly, we need to see at all these 3 points, the direct material, the department 1R and department 2R is coming within the limitation. Within the limitation, I hope you are getting how it would come within the limitation. So let's see. uh, I'm making 5 different material, department A and department B. So at this point, at first point, just see how many material would be used. So basically, if I'll make, suppose in the first scenario, I'm making 40 to 50 of product X and 40 to 50 of product Y. So what would, how many material units of material would be consumed? So I would say 40 to 50 multiply by 2, or I can say 80,000, 8,500 plus 8,500. So maximum 17,000 of material would be used. Okay. Now for department A, I'm saying for department A, what is the basically availability? Sorry, not availability. Use ratio. What is the use ratio? Let just a second. So for department A, I am saying 0.5 and 0.3. For department A, it is 0.5 and 0.3, and it is 0.4 and 0.45. Okay, so by what would be the maximum department A are used? So 40 to 50 multiply by 0.5. So it would be 2125, and 40 to 50 multiply by 0.3 plus 2125. So I am saying 3400 hours. Now 40 to 50 multiply by 0.4, 1700, and 40 to 50 multiply by 0.45. So it's coming 3612.5. 3612.5. So maximum available are maximum available is maximum available. It is 17,000. I would say it is available maximum at 34 and 3640. 34 and 3640. So everything is within the limit. Everything is within the limit. So the first option, we with first option we can go ahead. Means first option is somewhere, it is a feasible option. With the first option, I can further calculate the contribution whether at the first option we would be able to, get the maximum contribution or not. So the for third step, we can go with the first option. Basically we can go to calculate the contribution. We can calculate the contribution at first option. Basically at 4250 and 4250 we can see whether we are getting the maximum contribution or not. Okay, let's go with the let's see for the second. So 3700 multiply by 2 and 4800 multiply by 2. Okay, so I'm getting basically 17,000. Okay, I'm just seeing how many material hours are used. So basically 3700 multiplied by 0.5, 1850, and 4800 multiplied by 0.3. Sorry, 1 second. 4800 multiplied by 0.3 and 3700 multiplied by 0.5. I'm, I'm sorry, just a second. I think it would be 3290. Okay. And 3700 multiplied by 0.4, it is 1480. It would be 3640. So basically everything is within the limit. Everything is within the limit. So basically we require in the second option, we require 3640 of department BR, and we are maximum available with this. We require 3290 of department AR, we are available with 3400. So yeah, it is also within the limit. We require 17,000 of material A, and we are available with 17,000. So yes. Now for third option, 4171 multiply by 2 and 4381 multiplied by 2, 17104, 17104. 4171 multiplied by zero point 0.5, 3400, and 3640. So just see the third scenario. In the third scenario, I'm seeing that the as per third option, require I require 3640 of the department BR. I require 3640 of the department BRs, and I'm available with this. Okay, 3400 of department ARs, and I'm available with this. But I require 17104 kg material, but I am available with only 17,000 kg material. So basically, as per the third option, it should not be like this. It should not be like this, because we solved it as per the linear programming. But still we are as in this question we are getting material level. In these three options we require more material, so this three option got cancelled. With this three option this third option got cancelled. Why? Because as per this third option we require 17104 kg material, but we are available with only 17,000 kg material. Okay, so this third option got cancelled. Now see the fourth option, 6080 multiplied by 2, I would say 12160. 6080 multiplied by 0.5, I would say 3040, and 2430. So everything is within the limit. 16178. 2427. 3640. Okay, so everything is within the limit. Everything is within the limit. I think, yeah, I calculated this wrong. This would be 3400, not 3040. So everything is within the limit in all these. So the third option got cancelled. Now we'll see under these scenario, in scenario 1, scenario 2, scenario 3, and scenario 4, which scenario is best, in which scenario we are getting the maximum profit. So contribution at different level for scenario 1, X and Y. I'm seeing in scenario 1, 4250 and 4250. For scenario 2, scenario 3, scenario 4. What contribution we are getting? So basically contribution per unit is, what is the contribution per unit? We have already calculated it probably. No, we didn't calculate it. So we need to calculate what would be the contribution per unit. This would also need to be calculated. Okay, so I don't think it's that much difficult. So let's see it over here only. Let's see it in, because I do not have much space in my sheet. So let's see it here. Basically, we are given the sale direct material. Basically in direct material is 10. How 10? So basically 5 kg, 5 rupee per kg is the price, and we require 2 kg material for product X and product Y. So 10 and 10 would be there. For department A, I would say that it would be like 0.5 multiplied by 40 and 0.3 multiplied by 40. So 20 and 12 would be there. For department B, in the same way, 24 and 27 is there. Okay, so we have done this. Now we'll see the contribution. The contribution given to us is 36 and 31. Contribution given to us is 36 and 31. So let's write this contribution over there. I have not calculated contribution anywhere here, but as per the contribution, uh, we can solve the question. What is the contribution? 36 and 31. Contribution for X and Y. X is 36 and Y is 31. So 4250 multiplied by 36. It would be 15300. 153,000, sorry, plus 4250 multiplied by 31. It would be 131,750. Okay. 3700 multiplied by 36. It would be 133,200. 4800 multiplied by 31. 148800. 244. 250. 759. So 153,000 plus 131,750. It would be 284,750. 133,200 plus 148800. It would be 282,000. It would be 244,800 and 250,759. So we are getting maximum contribution in scenario first. We are getting maximum contribution in scenario first. So optimum would be 4250 of X and 4250 of Y. Answer. Since I'm not having much space, I wrote it like this. So it is the best scenario. So we have calculated the best scenario. So with this, the question number 1 is completed, I think. Sorry, this question is completed. No, the second point is also there. So we need to do it in the different sheet. Okay. Illustration 9, CA, final, continue. Second part. What is the second part? Let's see. In view of the aforesaid production capacity constraint, the company has decided to produce only one of the two products during the year. Which of the two products should be produced and sold in the year to maximize the profit? Okay, so it is easier one. Company is basically saying that instead of making both the product, we will produce only one product. Instead of both, we'll make only one product. So suppose only X is produced. Suppose only X is produced. Okay. So I will see that material, my department 1R and department 2R allow me to produce how many units. So if I'm producing X only, okay, and the maximum demand of X is 7,400. Maximum demand is 7,400. It is given to us. Okay. So if I speak in the light of material, since we are given, since we are given that we can produce only one thing, only one product out of those two. So we are seeing whether we need to produce X or we need to produce Y. Okay. So let's see available material kit. How many? What is the available material kg? 3,400 and 3,640. So maximum X can be produced. So basically, by using material, we can produce 8,500 units of material. Sorry, X. By using department A hours, I can produce 6,800 because we require 0.5. Uh, Basically, 0.5 hours is required in department A. It is given to us, and by using this department BR, I can produce 9,100. So basically, out of all these three, this is the least one. So I can say maximum 6,800 unit of X can be produced. I hope you got how I did this. Okay, this is not really difficult. If you are aware, if you are understanding the things, it is easy. How I did this? Basically, I calculated by using complete material how many units of product X can be made. By using complete department A hours, how many units of X can be made. And by using complete department B, how many units of X can be made. So least can be made by using is this. So basically only since we require all these things in all these three things in sufficient number. So by if I'm making 6,800 units of product X, I think it would be sufficient in department A. And since the department B's capacity is more than this, so it definitely if it can produce 9,100, 68 can be produced. Okay, so it since it is lesser than this, the 6,800 is the least we can produce. 6,800 at least 6,800 can be produced. Now suppose product Y is made. So same thing, material department A and department B. What is the available? I would say available R is 17,000, 34, 36, 40. Maximum Y unit. So I would say 8,500. Its demand is 10,000. Okay. I would say 34,000, 3,400 divided by 0.3. I would say 11,333 and 3640 divided by 0.45. It would be 8089. So since least is 8089, so I would say maximum 8089 units of department, sorry, product Y can be made. Can be made. Okay, now see the contribution. Basically for product X and product Y, units 6,800 and 8089. Contribution per unit, it is we have basically seen it from the book. We didn't calculate it, but it is easy to calculate. I hope you guys know. So total contribution. So it would be 257.55. And it would be 244,800. So if only one product to be made, it would be better to make a product Y, since it is giving more contribution to us. Answer. So I hope you guys understood this complete question. I hope you don't have any issue in this question. Still, if you guys, are not able to understand this, or you wanted to understand it once again, just let me know. Okay, we can do it once again. I can make you understand separately, because I understand the linear programming, it could be somewhere tricky for those students who do not have their maths very strong, or you know uh, who are not able to understand all these type of things. So yeah, this we can do. So with this, like, we have done one question from the normal thing of the optimum product mix, like if we are having only one limiting factor, and we have done one question related to the part where we are having two or more limiting factor. So we have understood all the questions, like both the questions, how it would be solved. Since I was planning to do one more question related to optimum product mix, like from CMA final study material, I was planning to do this question, the illustration 9. But now, since it's already been 1 hour, and I'm so what we'll do, basically we will solve this question after completion of the decision making. Since, as I told you at the very beginning, that after completion of the decision making, all the question from CA panel study material would be solved. Like, we are doing illustration continuously with the, when as and when we are solving the, we are reading any kind of concept, and we are, you know for to understand that concept, we are solving the illustrations given in the CA final study material. But since in CMA final study material, if I see, I think there are 25 or 35 questions. I'm not so sure, but let's see once. Oh no, we are having uh, 46 questions, total 46 questions in related to decision making in CMA final study material. So basically in CMA final study material, we are having, very good quantity of questions related to decision making. So only with this, you can understand how important this topic is. So what we'll do, we'll first understand all the topics once. We have basically done two topics. First is the, spatial order decision. So we have done two questions related to spatial order. Then today we have done optimum product mix. We have done two questions related to optimum product mix as well. So what we'll do, we will solve all those. Firstly, we'll read all these six topics, basically six concepts of decision making. After completion of all these six concepts related to decision making, at the end, we will see all these questions. We'll see how many questions, like we have already done, how many questions we need to solve here, and how many questions you can solve as your homework. Okay, so if I speak, only CMA final study material question would be left after completion of the decision making, because as I told you that we are already doing illustrations from CA final study material along with the topic, and all the question in test your understanding would be your homework. Okay, so this was really good question. I hope you guys understood the question. So this is all from my side for the day. Have a very nice day. Bye bye.